Okay, so we saw a very basic if statement. If this condition is true, or double line means, or this line, if this condition is true, then you do this statement, you just print out thanks. If neither one of those conditions were true, then you print out something else. There's a couple of things to notice. For example, the if is ended with a phi, sort of like the opposite of if, it's phi. And we have a then and an else. It turns out you can have else ifs too. So in general, you can have a number of other things. So the most general if statement structure is if some condition, then you do else if some other condition is true, then you do this, and so on. At the very end, you can have an else, or you can have no else ifs at all, just a if then else, like you're used to in Java or C. Okay, so that's the general structure, and we looked at one particular use of that if statement. Oops. Okay, so how do you do Boolean expressions? So in Bash, there's two ways to check something. They're both the same. So it's called the test command or the left square bracket command. And it turns out the test command is an executable file that you can find in /user/bin. So let's just try that out. So ls-user/bin/test. There it is. It's a 30,000 byte file. It's an executable file, and you can check what it is by using file. It turns out it's a regular executable file, the kind that you would get from compiling a C program. Okay. So you can use if test, or you can use what we had in the script that we just looked at, it is open square bracket. Now you might say, well, how can you use either one? It turns out this open square bracket is actually a command that you will find in /user/bin, I think. You can look. ls/user/bin/open square bracket. Sure enough, there it is. It seems odd, but that's how it works. If you use file to see what it is, it's just like test. And let's see how big it is. ls-l. It's not quite, well, it's actually a little bit bigger than test. It's 34K. So it seems kind of strange. It looks like the open square bracket is actually a file. That's what it is, even though it looks like part of the language. It isn't part of the language. Okay, so you could have used if open square bracket space minus f $1, and it has to be in that order. You can't say $1 minus f. It has to be if test minus f $1 with spaces in between, or if open square bracket space minus f $1, like we had in the other script. Okay, so this is one good reason to avoid using the name test in file names, because test is also basically a command that you can have in your scripts. So like we saw, the command /user/bin/open square bracket is also used to check conditions. The last argument has to be a close square bracket. So if you use open square bracket, you have to have a closed square bracket that tells the open square bracket that now the arguments to this, it's basically a test, have ended. Okay, so it's kind of screwy, but that's how bash works. And there's in the book you can see page 386 to 390 for tons of things that you can test, and it's just, I'm just not going to go through it just yet. I probably will set up a different lecture or video with options. But in any case, look in the book. These pages will list all the different options. There's so many. It's just so hard to list all of them. But once you know how if statements work, you can go and refer to this and find the particular thing that you're looking for your shell script. Okay, let's move on now to variable names. If you did something like this, there's a problem, take a few minutes if you want to pause this video and see what exactly is the problem. So see if you can guess, pause it now and check. Okay, so if you found the problem, good for you. And I'll tell you right now what the problem is. So this is fine. You're assigning a string to X, checking if this string myfile is a file in the current working directory. If it is, then you do something. You make a copy of myfile called, and this is what you want to do, myfile backup, but this won't work. The reason is this. The reason is that $x is one thing and $x backup is one thing. So the way bash treats this, it won't treat this as $x with the string backup added to it. It just treats it as the variable $x backup. And remember, in scripts you don't have to define variables, so if you don't have to define x backup, it just assumes that this is nothing. And so it'll say you're trying to copy this file to nothing, you need one more argument to copy, therefore I'm not going to do anything. So this copy will fail. This will not work. So the problem is not with the copy command. Its problem is really that we want to use the name myfile, plus we want to append backup to that name. But you cannot do this. So there's a whole bunch of things that bash has as far as variable names to allow things like this. The main way to get around that limitation is to quote-unquote protect the variable name. And you'll see this word protect used in this way. And what we want to do is say that, well, this $x is one thing. All right, and then we want to attach the string, attach the letters backup to that $x. And this is the way to do it. If you use this open curly brace, x, close curly brace, this protects the variable name and says, okay, this is the name of the variable. Take the variable $x and then attach or concatenate the string backup to it, and now everything will work. What will happen is if you have a file called myfile in your current working directory, you will check if myfile is a regular file, and if it is, you'll make a copy of it. Great. So the thing to get from this is just that you can use open close curly braces to protect variable names. And then there's a whole bunch of different options. We're just not going to have the time to cover all of them, but I'll try to go through a few of them. So besides protecting variable names with the $ and curly brace syntax, we can also use it to test values and make changes to it. So for example, if you use, for example, let's say you have a variable x and you say open curly brace x minus and then some other variable name, what this has the effect of this whole thing will be equal to var if it is set. So if you have an x here, this will just be $x if x has already been set. But if x has not been initialized, this whole thing will have the value of the variable $default. So it's assuming that you have actually defined a variable called default before this. Okay, so these are just names. This is just a name, var is just a name, and default is just a name. if var has not been set, this whole thing will have the value of the variable, the second variable, which in this case is called default. Okay. You can also use it, instead of a minus, use an equal, and what that will do is if var is not set, not only will this whole thing have the same value as the second variable, $default, but also it will assign the value of $default into var. So this is like saying if var is not set, assign var the value of default, and this whole thing will evaluate to default. Okay, so the best thing to do with these kinds of variable name substitutions is to try it out. Just set up a few variables and try out these things. Let's take a look at a couple more. If you have $var plus new, then this whole thing has the value of this new variable if var is set. So if var is already defined, then you get a new value. If var is not defined, then this whole thing is undefined. Okay. Now another option, there's actually even more than this, and we're just going through a few of them. So let's say you have $var colon question mark new. This is sort of the opposite of the one we just looked at. If var is already been set, then it just returns the value var, and if it has not been set, it returns the value of new. Sorry for this exit script. This should not be part of the. So just ignore that. Okay. So there's a few more of these variable substitutions. You might want to print this out and keep it handy. Every once in a while, one of these will come in to be very useful in a script. Okay, so here are some more illustrations. So let's say you use the minus. This is saying if, let's say, area code is defined to have the string open close parentheses 510. So this is area code 510. So right now you use this. Right now area code is 510. If you use this variable $area code and then colon minus, since this has already been set, the value of this whole thing in this box is the same as the old value. So if you go back, it's this case. So the value of this whole thing is the first value, but if it's not set, then it will have the second value. So that's illustrated here. Let's say area code has not been defined, and you can try this. You can just not assign a value to area code and then then echo this thing. What you will see is since area code is not defined, the minus says, okay, area code has not been defined, so the value of this whole thing in the box is just this part. Open close parentheses 408. Alright, so there's a couple more examples, and you can try this. What you can do is say area code equals open parenthesis 510 close parenthesis, and then echo this whole thing without the space, and what you will see is it'll print out 510. Then take out the area code equals 510, so that area code is not defined, and then echo this, and what you will see is this 408. Okay, and then also echo this and also echo area code, and you should see that area code will now be 408. So try this too. Assign this to name and then echo this. Then take out the assignment to name and just echo this, and you will see. Try same thing with the colon plus. Make sure that you know how this works.